On the screen. Hank, why don't you read that to the class, bud?
Oh, why do you stick on me so much?
Just because you're new.
Yeah.
Exactly.
Go ahead.
How to make your 8.5 by 8.5 by 8.5 presentation cube.
Very good. So, this is a recording. I'll post it on Google Classroom. But I want you to be able to make your own 8.5-inch cube. Okay? You're going to have duct tape, a knife. If you don't feel comfortable using a knife on your own, please don't do it. Ask your parents. Someone in your household should be able to use a knife without cutting their fingers off. Okay? I'd like you to just take a little half scoop back so I don't cut anyone else's fingers off. But how wide should I make a square that is going to be one surface of an 8.5-inch by 8.5-inch by 8.5-inch cube?
8.5 inches.
Very good. Okay, so I'm going to make my markings with my knife. If you don't feel comfortable with a knife, just use a pen for the markings. Okay, it's actually way more accurate to make your markings with a knife. If you're just talking, please quiet down. Good job, Hank. Okay, so right now I'm not cutting all the way through the cardboard. I'm just scoring. I'm just making a mark. Now, cardboard is really cool because you can go like that, and it folds usually right on the cut. Okay, so this is 8.5 inches wide, but the problem is it's really long. Okay, who knows when you're making a cube? Should I make it 6 separate squares and then try to tape them all together? Yeah, your net. Very good term. I could make a net, but I wanted to make this as simple as possible so everyone can go home and do it first try. Okay? So what I'm going to do is make 3 rectangles. Each rectangle will be 8.5 inches wide. And how long should it be if I want to fold it in half and make 2 surfaces? Joe?
17.
17 inches even, because 8.5 times 2 is 17. Okay, so this will be 17 inches long. I'm going to mark exactly 17 with my knife. And then I'll cut. And I could make this cut way longer because I know that I'm going to cut 2 more rectangles after this one. So I'm going to actually just go all the way to here and score it. Okay, I'm not cutting all the way through because then I would make the table messed up. Okay, and I'm going to measure this way 8.5 for another edge, and I'll mark it. And I could just measure again 8.5 for that third rectangle, and I could go to 17 here, find 8.5, and then find the end. Okay, I know you've all done this with paper before. Who here has done this with cardboard? Made some kind of shapes or anything with cardboard? Kieran, very nice. Great.
Wait too much for that. I'm taking it for 3 seconds.
Good job, Kieran.
So I'm scoring where I will cut for real, and you can cut with scissors if you want, but it's going to be neater. Is that the same as that?
No.
Oh, what happened there?
It wasn't.
8.5, 17, 8.5, 17. Do you think it'll be close enough?
No.
We'll see.
No.
If I think it's like 1/8 of an inch off maybe,
Nothing you can't fix it.
but we'll see. So this next cut, I'm going to do the long one, and I think I'll cut it in half first so it's more manageable.
Can we see it first?
Let's see.
He's coming through. It's okay. Good job, Puffy.
Notice my hand is not underneath where the blade's going to go. I'm not cutting my finger off. See how my cut's not perfect? It's kind of wavy. That's gonna be fine in the end, okay? It's going to be okay. I know some of you are nervous about making something like this. Uh-oh. Notice my hand. I'm not doing it perfectly because it's going to be okay. Once again, I scored one side so it folds perfectly. And I want everyone to watch this awesome cardboard trick. You know this one, Kieran? Okay, I folded it. So now I can
Go under.
go under
Yeah.
and cut right where that fold is. And I'm not cutting my finger off. I'm being very careful. Thank you so much. Now I can do the same thing to this fold. Don't cut towards yourself. If you do, be very careful. I can cut right along that fold. And I'm not putting my hand here because I would cut it. Okay, if it's a little off, it's gonna be all right. Kieran,
This is how much you do what I usually do. I usually put like, little like dots in it and just scissor.
so it's really sloppy.
Yes.
Way to go, Karen.
So once again, my hand is not here. It's off to the side, so when the blade passes, it doesn't cut my fingers. Okay? Artem, could you do this at home, you think? I think all of you could do this at home.
Not me. Yeah. Maybe at training point.
I'm gonna make sure all three rectangles are pretty close in size. Now, the reason it's 8.5 by 11 is so a piece of paper fits perfectly widthwise. Okay? Now, when you print something to put on your cube, I expect you'll probably print part of your analysis, you'll print your question, you'll print it out, cut it to make it a square, and then you'll be attaching it to the cube, okay? There are 6 sides to a cube, right? We discussed this before briefly. But you get to put 6 things on your cube. 5 parts of your project need to be on that cube, okay?
What about the sixth part?
It's gonna be on the bottom.
The 6th part, I think, should probably be a picture
But it's the
or
bottom.
a
No, but someone can like
graph.
pick it up and go like.
Or, yeah, it's gonna be, so that's the reason it's a cube, right? A lot of science fairs, you walk in and everyone has a poster board. And honestly, poster boards are a ton of work. You could put 10 hours into a good science fair poster board. And I don't want you to spend 10 hours on it. I want you to spend time on your video, Izzy, and time on your cube, and time learning what to say, reading your analysis, going over it, okay? I'd rather have you spend time doing that rather than decorating a poster board you're gonna use for one night and then recycle. Connor.
So after we fold the pieces of paper to be a square and put it on there, we can
Fold it and cut it. Did I not say that? So you'll fold it, and then you'll probably use scissors to cut it, so there's not a sloppy looking fold underneath the paper.
Okay, and
Okay.
then after we put the paper on the cardboard, we cut the cardboard to be square as well.
So what's going to happen is I'm going to make my cube first,
Oh, okay.
and then I'll put the paper on.
Oh, that was cute.
So,
okay. I thought that was.
I think some of you didn't understand why we're doing a cube that's 8.5 by 8.5. It's a really good reason, so you can just print something out and put it right on there. So who has an idea of how they will attach their paper to the cube?
You.
Hannah, what do you think?
Glue.
A glue stick?
Yeah. No, like the glue that you squish in like flex tape.
That's a lot of damage.
Did everyone say I folded that really nicely? I scored one side. Okay? You're gonna use these hints in making your cube. If you don't, you're gonna have a really sloppy looking cube.
When is your cube?
Your cube is due when you come to the science fair, or drop your stuff off actually, which is the day before. You get back from spring break, and then things are due right away.
So did we do the analysis?
Oh, so things that do is the end of the
So have you seen the timeline on Google Classroom?
You can.
That's it.
Oh, I just.
That's it.
First week.
There's another edge. And I need to get to 8.5.
I can't even see it.
How you doing, Lionel? Yes. Shh, listen up. Mercer has a question.
When we print out our analysis and question and hypothesis and everything like that, do you, for your question, does it have to be like, can you do that on like a separate document, or does it have to be on the same document as every single page? Like that big document, or can you?
When you print sheets out to put on this cube, I want to see question and then have your question.
Okay.
I don't want to see prediction underneath that on
Okay.
one surface of the cube.
Okay.
I want someone to come up and say, oh, that's the question. Rotate the cube. Oh, that's the analysis. Rotate it. Oh, that's a picture of you doing it, right?
Yeah.
Okay. So I don't want to have too much on one surface. So this is where I attach everything.
What about the table of contents?
You don't need the table of contents because it's a cube.
It's supposed to be like taking notes on these papers.
If you need to take notes on that paper to remember how to do this, you can. But like I said, I'm going to post it on Google Classroom. So right now what I'm doing is taping an edge so it will fold into a cube. Okay? It's okay to have the duct tape showing right now because I'm just going to glue the paper on top of it. Okay? So now you can see the cube coming together. Okay? This will go here, and I'll have a cube. So how many edges do I have to tape?
11 more.
Flex tape can handle any box.
5, 6, 7, 8, 9, 10, 11, 12 sides minus 1, so 11.
Why minus 1?
8 vertices.
What's that
How many
big
total will you have?
15, 12.
8 vertices.
No, because it doesn't have
Ooh, who said that? Izzy said 8 vertices. There are 8. Izzy, there are 8 plus 4.
That's 12.
1, 2, 3, 4. Can you count them on the bottom of that? 5, 6, 7, 8. Okay. 5, 6, 7, 8. Right? And then the 4 that we missed are here. 1, 2, 3, 4. So 8 plus 4 is 12. There are 12 edges. It doesn't have to be duct tape, but please don't use Scotch tape. Don't use Scotch tape because it will fall apart.
What about flex tape?
If you want to use a different type of tape, that's fine. Just not Scotch tape.
Yes, Hannah. My sister has Scotch tape.
What about flex tape? It's still on your wire? You're gonna flex tape.
Mr. Smith, can we have
Hey, listen up. Listen up. What's your question? A background like one. So you're not going to see the box because you're putting the paper on it, and the paper is going to cover it. Someone asked that already. Luke, when is the box due?
After you come back from spring.
Are you blue?
When you bring your stuff.
Oh, the day.
When you bring your stuff to Science Lab, which is on the timeline already on Google Classroom, you should bring your cube too. I'm going to be setting up the science fair, putting tables out in the hallway, organizing all the exhibits, right? Your exhibit will pretty much be the cube. The day of the science fair, you'll have your Chromebook, and you'll be playing the video that you made. That said, I put a video up on Google Classroom yesterday. Who saw that and can tell the class briefly what it was about? Hannah.
It was about how to put a graph into Google Drive from Google Sheets, and like you're supposed to copy the graph that you did on Google Sheets, and then you put it into Google Drive, and so don't just do the one that's on the Google Drive. Take it from
So, do you want the sheets to go on the analysis?
I'd rather just
So-
watch the video.
Literally, it was like
You should watch the video.
doc on the sheet and then the sheet on the doc.
Hudson, stop it. Okay, you should watch the video. because it goes into great detail. It's 13 minutes long. Does that sound about right? I made a couple videos. It's not the most exciting video. I don't want to go over how to do that in class because we do other stuff that's more interactive, like we'll get to in a second. But I do want your analysis to include tables and graphs, like we've talked about before, and they should be from Google Sheets. Like you've been tracking your data in Google Sheets, right, Joe? Yeah. So you can link that table to Google Docs, which is where your big document is, where you're keeping all the information. Joe, what's your question?
You had 2 subscribers.
Thank you for that. I'm not, actually, my videos are unlisted. So I'm not looking for subscribers because that's weird. I don't want to monetize
But if you want to
my
subscribe.
teaching videos. Val, listen up, Val.
So the videos due next Thursday. And can
I think I said Friday.
next Friday. And can you just demonstrate what your experiment was in the video instead of having to recreate it?
Yep, I handed out that paper yesterday to everyone, or the day before maybe, and it said the analysis expectations and the video expectations. I can upload that to Google Docs. This is exactly what it is. This sheet. I'll upload that to Google Docs so you see it. Can you go over the video real quick? Can you read that out loud?
Must be 90 seconds long. Have a title with your question. Your first names only, no last names. Show you conducting your experiment. Explain how you analyze your data, what your results show, and what it means for the
Skip that parentheses part.
Show you're conducting your experiment or recreating it.
Or recreating it. So if you didn't get good footage of you, I'm sure a lot of you went out with your iPhone or your phone and took a video of you doing the experiment. Then you watch that video and it was probably terrible because you're shaking, you're not, the audio, you can't hear it if you try to do audio, okay? You can reenact it and maybe put the camera on something that stays still, maybe put it on a tripod if you have that, but the video should be as good as you can make it, right? Someone said they have editing experience and they want to make a slightly longer video. That's fine. I'm gonna make the cap 3 minutes. It needs to be between 90 seconds and 3 minutes. So I've ripped 12 pieces of duct tape because there are 12 vertices. Right, Izzy? Count them.
What? No, those are. I've learned that.
Oh, edges.
Yeah.
Edges, sorry.
Yeah.
Good job, Izzy.
Okay. I was
Okay.
like, I got that
So,
wrong.
does everyone understand how to make a cube? That's the simplest way. There are more ways. You can make a net. You can make it like a cross, right? And make it all fold together. I just made 3 rectangles and cut them in half or fold them in half. You're gonna print out something, and each edge will have part of, this is a regular piece of paper, 8.5 inches. It's just cut to be 8.5 inches the other way, okay? You'll glue it together. Now, we're done with the box demonstration. Anthony, do you have a question?
In the video, can you?
Shh, I wanna hear Anthony's question.
In the video, can you also add a part of you making the box?
This is it.